Imagine for a moment that you've just stepped into a gleaming machine, a contraption that promises to catapult you through the mists of time. A thrilling notion, isn't it? The allure of time travel has captivated our collective imagination for generations, sparking curiosity and igniting debates about the very fabric of our existence. Time travel is a tantalizing enigma wrapped in a mystery, a concept that has been woven into the tapestry of our culture. Think of H.G. Wells's seminal work, The Time Machine. It's a tale that has enthralled readers for over a century, painting a vivid picture of a future shaped by the hands of a time traveler. It's the paradoxical nature of time travel, the possibilities and the dangers, that continues to fascinate us. Speaking of paradoxes, they're rather unavoidable when we delve into the realm of time travel. Consider the infamous grandfather paradox. This thought experiment asks you to imagine traveling back in time and meeting your own grandfather before he has children. If you were to prevent him from having children, then you would never be born, and thus could never have traveled back in time. It's a mind-bending conundrum that has left even the most brilliant minds scratching their heads. Yet paradoxes are not the only challenges we face when considering time travel. There are also questions of cause and effect, continuity and change. If we alter the past, what happens to the present? If we glimpse into the future, could we change our destiny? These questions take us into the heart of the mystery, the enigma that is time travel. So is time travel just a captivating fantasy, or could it be a scientific reality? As we venture further into this exploration, we'll delve into the theories and experiments that have dared to unravel this riddle. Buckle up, dear listener, as we prepare to embark on a journey through time. Opening. To answer that question, we first need to delve into the mind of one of the greatest scientific geniuses of all time, Albert Einstein. Einstein, a name synonymous with genius and innovation, gifted the world with his groundbreaking theory of relativity. Imagine a universe not governed by an absolute, inflexible time, but by a relative one that bends and flexes under the weight of gravity and speed. Sounds surreal, doesn't it? Yet that's the universe Einstein envisioned. In his universe, time is not a constant entity, but a flexible fabric that gets warped by gravity and speed. Picture a trampoline. When you place a heavy object on it, it dips and curves under the weight. Similarly, space-time curves around massive objects like stars and planets. This is the essence of Einstein's general theory of relativity. The implications of this theory for time travel are profound. It suggests that if we could somehow harness enough energy or speed, we could bend this fabric of space-time, effectively allowing us to travel forward in time. But how does that work, you might wonder? Well, Einstein proposed that the stronger the gravitational field, the slower time passes. This is known as time dilation. An astronaut traveling at near light speed in space would age slower than his counterparts on Earth. So, in a way, he'd be time traveling into the future. Einstein's special theory of relativity also presents an interesting concept: the idea that there's no universal present. What happens simultaneously for one observer might occur at different times for another. This opens up a fascinating, albeit mind-boggling possibility of experiencing events out of sequence, much like time travel. These theories, while complex, have been supported by numerous experiments and observations, solidifying their place in our understanding of the universe. Yet despite their implications, we've not seen any DeLorean DMC-12S whizzing through time. Closing. But if Einstein's theories hold true, then why haven't we seen any time travelers yet? The answer may lie in a peculiar phenomenon known as time dilation. Now, let's take a moment to dive into the concept of time dilation. It's a fascinating concept that comes straight out of Einstein's theory of relativity. Time dilation describes the idea that time passes differently depending on how fast you're moving or how close you are to a gravitational field. Let's think about this in a real-world context. Imagine you have two atomic clocks, precise instruments that measure time based on the vibrations of atoms. One of these clocks stays on Earth, while the other is sent up into space on a GPS satellite. Now, according to Einstein's theory, the clock in space should tick slower than the one on Earth due to the weaker gravitational field. And guess what? This is exactly what we observe. When the space-bound clock returns to Earth, it has recorded less time than the Earth-bound clock. It's a minute difference, sure, but a measurable one. This means that the astronauts on board the International Space Station, for example, are actually aging slightly slower than us down here on Earth. They're time travelers, in a sense, journeying into the future at a slightly different rate. Now, this might seem like a far cry from the kind of time travel we see in science fiction, but it's a start. It gives us a real-world example of how time is not absolute, but relative. It confirms that time travel, at least in one direction into the future, is not just a pipe dream, but a reality, albeit on a minuscule scale. But it also raises a host of new questions. If time can be dilated, can it also be contracted? If we can travel into the future, can we also journey into the past? The answers to these questions are still a mystery, and the hunt for a solution continues. So we can theoretically travel into the future, but what about the past? To explore that possibility, we'll have to dive into the strange world of quantum mechanics. Now, don't fret, we won't get lost in the labyrinth of complex equations, but instead we'll focus on one of its most fascinating predictions: wormholes. Imagine a wormhole as a sort of tunnel, a shortcut through the fabric of space-time. It's like folding a piece of paper in half and pushing a pencil through it. The pencil doesn't need to travel across the paper's surface, it just goes straight through. That's the magic of a wormhole. Theoretical physicists like Kip Thorne have spent a great deal of time pondering over these cosmic shortcuts. According to the laws of quantum mechanics, wormholes could exist naturally in the quantum foam, an underlying structure of the universe. However, these would be so tiny that they'd be practically impossible to detect, let alone travel through. But what if we could create a larger, more stable wormhole? Many scientists believe that with enough energy and advanced technology, we might be able to expand one of these quantum tunnels. The resulting wormhole could be large enough for a spaceship, or even a human, to pass through. Here's where it gets interesting. If a wormhole could connect 2 points in space-time, then it could potentially allow for travel not just through space, but also time. That's right, a journey into the past might not be as far-fetched as it sounds. Now, of course, we're still far from turning this theory into reality. We don't yet have the technology or the understanding to create or manipulate wormholes. But the fact that they're even theoretically possible is a testament to the mind-bending possibilities of quantum mechanics. But even if we could create a wormhole, would we dare to step through it? Time travel isn't just a scientific challenge, it also presents us with a host of ethical dilemmas. As we delve into the intricacies of time travel, we're confronted with a Pandora's box of potential risks and ethical quandaries that stretch the boundaries of our understanding, our morality, and our very humanity. Imagine, if you will, that you've successfully journeyed back in time. Now you're faced with a choice. Do you interfere with the events of the past, perhaps to prevent a tragedy or alter the course of history? This idea, often referred to as the grandfather paradox, presents a profound ethical dilemma. If you change the past, you might drastically alter the present and future, disrupting the timeline and potentially causing harm on an unimaginable scale. And then there's the issue of responsibility and accountability. If you're able to jump through time, who's to say you won't use this power for personal gain or even to commit crimes with impunity? Time travel in the wrong hands could become a tool for manipulation and exploitation. Furthermore, consider the implications for personal identity. If there are multiple versions of you existing at different points in time, then who are you, really? Are you the same person you were 10 years ago or 10 years from now? These are questions that challenge our fundamental notions of self and continuity. Let's not forget about the potential physical risks. We don't know what kind of dangers might lurk in the depths of time. Could time travel cause physical harm or even death? Could it disrupt the fabric of space-time itself? Time travel, then, remains a tantalizing mystery, a journey not just through time, but into the very heart of what it means to be human. As we grapple with these ethical dilemmas, we're forced to confront our own limitations and imperfections. We're reminded that as much as we might long to control time, we're ultimately at its mercy. But perhaps it's these very challenges that make the idea of time travel so endlessly fascinating.